So today we're going to look at 5.4, equations and graphs of trig functions. We're looking at more word problems, basically. You can use sinusoidal functions to model periodic phenomena that do not involve angles as the independent variable. For example, some wave shapes like the heartbeat or the ocean wave, pistons in a machine, as well as Ferris wheels, swings, pendulums. Okay? You do that by adjusting the A, B's, C's, and D's. I always write C's and D's, but you guys write them as H's and K's, right? Throughout, it depends on the textbook maker. It really does. When I used to teach them, there was P's and Q's as well. So it really depends on the textbook maker. So it used to be H and K's, P's and Q's, or C's and D's. Okay? So basically, those are your horizontal and vertical shifts. This is your amplitude, how big of a height it's going up and down, and this B changes your period length. Now, if you're dealing with sine and cos, it's 2 pi over B. If you're dealing with tan, it's going to be pi divided by B. Okay? Does someone want to go check on him? Not you. Text him. Someone text him, see where he is. Okay? Graphing technology helps you find things. We were using the graphs to find the x value or the y value for that x, or hitting the tan. I think he might be coming here. But it also allows you to extrapolate or interpolate values that you might not know that don't fall in those pi quarters or pi halves or whatever your quarter period shifts are, right? And you can find approximate solutions by solving the equation using your calculator, okay? So, solve each equation over the specific time interval.
Oh yeah, he has a nosebleed. That's why he's in the bathroom. He's got a what? Nosebleed.
He's got a nosebleed.
He actually had it in class.
Yeah, he does actually.
Does,
And it's been happening for like.
can someone go?
Okay.
No, here. Okay, so basically, you have to be able to solve for multiple solutions because remember that sine really goes like this, right? So where is sine 0.5? Now he's leaving. Right here, right here, right here, right here, right here, right? So where is sine equal to 0.5? Halfway through, and if we're going to 720, one cycle is 360. So 2 cycles, I don't even have it. 1 cycle, 2 cycles right here. So how many answers am I going to end up having? 1, 2, 3, 4 answers, right? So where is sine theta or sine x is equal to 0.5? What's 0.5? 1/2, right? Now, we know by using our unit circle, that's 30 degrees, or using our table that we solved, that's 30 degrees. So this is 30, and if we think like that, that's 30, that's what, 60? And then to do a whole cycle again, it's like 360, so it's 360 plus 30, it's 390. And 60 plus 360. Oh, this isn't 1/2. It's not 1/2 there. It's root 3 over 2 at 60, right? So this one should be 150 degrees. I agree with you. That's where sine is positive 1/2. Thank you for that clarification. So sine is 1/2 at 30 degrees, and the reference angle of 30 degrees from the second quadrant, so 150, and then we do the coterminal arm for the next one, 360 plus 30. So we add 150 to here, or no, we'd add 120 to that, right? Because it's from 30 to 150. Or you take 150 and add 360. 150 plus 360 is 510, right? So that one was a nice one to solve for because that's a reference angle. We know what the sine theta equals 1/2, right? They'll ask you to do these ones where you can solve, okay? So this next one is root 3 tan x minus 1 times cos x equals 0 from 0 to 2 pi. So what do you do if it's factored like that? You set each factor to 0, and we solve. So we add 1, divide by root 3. So we get tan x equals 1 over root 3, which is just tan x equals root 3 over 3, because we have to rationalize that denominator. And the other one is just cos x equals 0. So where's tan x equal to root 3 over 3? I pull out my unit circle all the time, and especially if I did that thing that Jesse had said to do the tan as your third comma thing, right? So this would be root 3 over 2, 1/2, and that would give me root 3 over 1. This will give me root 3, right? So that's the pi 6's, but the pi third is 1/2 root 3 over 2, and that's root 3 over 3, right? Did I do that backwards? Root 3 over 3. No, sine divided by cos. I did this backwards. You're right. Do my tan. This should be 1 over root 3, which will turn into root 3 over 3. And this one is just root 3 up here. So my real answer then, whew, I think you guys are here to help me, is that one. That's pi 6's, right? So tan is equal to positive root 3 over 3 at pi over 6. That's one of my answers. And where else is tan positive? Here, right? And this is the reference angle of pi 6's, so 6 pi 6, 7 pi 6. Okay. Now where is cos equal to 0? This is 1 comma 0. So this is here, pi halves, and down here, 3 pi halves. Everyone has different minds, and everyone remembers things differently. It's okay. Here's our answer. Those are our 4 answers where it falls in. You guys okay with coming up with those answers? If they are exact values to solve, right? It's really finding your unit circle, figuring out where cos or tan or whatever is positive and where does it equal that value. Okay? Now, graphically, sine 2x is equal to 0.5. That is a b value, right? That's a b value. What does that do? That changes your period length, right? What does it change in our period length? Well, our b is 2, so our period length is 2 pi divided by 2. So our period length is pi. That means every single thing we have to do we have to take that period length divided by 4, right? So every single tick mark, quarter mark is pi quarters, not pi halves, right? So every tick mark is pi quarters, but we're doing 720. So I really should have done 360 divided by 2, right? So our period length is 180, but we know pi is 180. But every tick mark is going to be pi quarters, but what is pi quarters? 180 divided by 4, so that's 45, right? So if I do this, and try and do this really nicely, we have to go up to 45, 90, 135. Do you see how tight it is in here? You all right? Okay. They were more worried than me, just so you know. They thought you were gaming and they really wanted you to get caught. Now you're just going to call me out like that, hey? Okay, so do you see how it's going to get really, really tight in here if you write every 45? Because we have to hit all the way to 720, so I'm going to have to use every block, right? But instead of writing it out every 45, what should we do? Maybe do every 90, right? 90, 180, what is it, 270? 270, 360, 450, 540, 630, 720, right? Whew. Now, there was no other A, B, C's, or D's, right? It was just that one B. So cos or sine will jump between 1 and -1. So it might be easier if we stretch our 1 and our -1 out like this, just so we can see what's going on. Now, if we're graphing it, it's sine, right? So it starts at 0, goes up to 1, goes down to 0, down to -1. We're going to use every single block because,
Ones are spaced differently.
oh, yeah, you do. I'm really falling to,
Top one's 5 and bottom one's 4.
oh my goodness. 1, 2, 3, 4. Yeah, we have to go in between the 90s because of the fact that our pi quarters, like if I take this divide by 4, I need to go up by 45 degrees. Each quarter is 45, so each placement of a dot is 45. That's what taking your period length dividing by 4 does. Tells you where you need to place every single dot, 45 degrees away. So starting at 0, then going up to 1, down to 0, down to -1, up to 0, up to 1, down to 0, down to -1, back up. So if we look, we just did 2 period lengths in 360 degrees. Then we will do 3 period lengths, 4 period lengths here. And you get a nice sine graph like that. Now this is just saying estimate, so it doesn't mean that you have to be for sure, but you should have somewhat of a nice curve. And when we take a look, we're trying to estimate where is it equaling 0.5. Where is 0.5? 0.5 falls into play right here, right? That's where 0.5 is. So at this point, 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 right? Whew. We can guess, right?
So is this where you need to kind of back
This is, we try to be as accurate as we can. It's not going to be perfect this way. It hits here, this is 45. It's probably maybe a quarter. Do you have it as half? I have it, some people have it as half, some people have it as a quarter. Do you see how it's going to be difficult for us? So maybe it's going to be like 15. Maybe it's going to be 22.5. Now, someone's already popping into our favorite thing, right? Our graphing calculator. So let's pull that out just to see if we can't get something drawn. Now, notice our x-axis is 0 to 720. So guess what? We're going to want to keep it 0 to 720 when we do our scale on our graph. Okay, so I'm just going to come in here. Now, can I tell you something? When we actually go to do this, I hit sign, and the bracket pops up right away. So here's the thing. When we're entering it into our graphing calculator, your B has to be placed inside that bracket. So if you have a H, you might have to do something if you're going to graph it like this. Okay? And we might get an example like this today, we might not. This is 2x, right, is what we're graphing. I'm also going to put a y line at 0.5. Why? That's what we're looking for. Okay? So I'm going to go into my windows. My x min, I really don't care. It should be around 0. My x max, we want at least 720, right? So maybe I'll do 730. And my y, I'm just bouncing between 1 and -1, right? So why don't I put it as -2 and +2 so I get a really nice stretched out graph. Okay? I'm just going to check my mode. My mode should be in degrees because this is one of the questions we're dealing with in degrees. I hit graph. You'll see this nice sine graph pop up, right? You get your sine graph drawn? Once it finishes drawing our sine graph, you can see it draws that line at 0.5. That's roughly where we were at. How do we find these points where it hits? Well, we can do a couple different things. I can go second, trace, intersect. I'm going to go all the way. If it's in radians, it won't work like this. Yeah, it'll be really, really squished.
No, it was like filled in.
Yeah, because it goes up and down, up and down, up and down so many times. Because 360, 180 is a period length in degrees. Okay. So if you do this trace thing, this I get 16.5. I did pretty good guessing, you guys, on my graph at 15, right? This one says 16.5. Then I can do a second intersect. So second trace, intersect, and I can go over to the next little bump. Now this could get annoying doing this over and over again because we have to do till 720. Do you agree? Okay. Now if you go second graph, we need y equals 0.5, right? Oh, I'm way back at 35. We need the x value when the y is 0.5. Do you see that? 0.5 and 15. And then we have to scroll through until we find 0.5 again. So this would be annoying too because you have to scroll everywhere until you hit a 0.5 because it'll go back.
Well, if it went from 15 to 45 and that was going up to 1, it'd be the same to go back down to 1.5, so you're going over 2 degrees, right?
Oh. So you're thinking at 75 it'll hit 0.5 here?
Yeah, it does.
Ta-da! So you can notice a pattern is what he's trying to tell you, right? You can notice a pattern so you can always see where it's going to pop up and pop down. So once you find the first two, you just add 360 to that one again, add 360 to that one. Is that what you're saying? Once you find your first two, you should be able to notice a pattern and add 360 to them. Because like here, it's here, and then, oh, but not 360 in this case, because our period length is not 360. Our period length is 180. So if I add 15 plus 180, my next one should be at 195, right? Now, instead of scrolling down to 195, I'm just going to change my table setting and start at 195. And at 195, it's 0.5, okay? And then 75 plus 180 will give you your next one, okay? Or 180, whatever your period length you need to do is to add them, okay? So 15, 75, 195, 180, 255, and we'd carry on, right? And so then you take 195 and add 180, take 255 and add 180, take those answers and add 180, and you'd end up with all those answers. Because to get back to this point, you're doing one period length. And that one period length, in this case, is 180 degrees, because that's our period length. Is that good? So, that's that graph of 6 cos 4x. So the amplitude is 6. 4x means your period length. 2 pi divided by 4, right? Oh, but is equal to 3. Where is it equal to 3? But this is your period length, that's your b, so 2 pi divided by 4. That means your period length is pi halves, right? Right? I didn't finish writing them. I'm lazy. So, what did you say the rest were, Jesse?
255.
Yeah.
And 375. And 435.
We just keep on adding 180.
And 555. And
6, 15. Okay, sorry. So we've got a period length of pi halves. We know we do because if you look here, it starts here, it ends here. We can look from 0 to pi halves. If we go here as our starting point, there to our ending point, pi halves to pi, that's still a pi half period length. But we can also calculate it by knowing that the b value was 4 and finding our period length. So if our period length is pi halves, each quarter section is going to be pi eighths, right? And where is it equal to 3? Well, this one actually turned out really nice in the sketch that it falls right on the line, right? Now we just need the answers from 0 to pi. So this one at the end here is not one of the answers. Now, can we read straight down? Do we know what this thing is? Well, we know this is pi halves. But how many little dots do we have here? 1, 2, 3, 4, 5, 6 dots. Do we not? So careful with your scale, because they didn't make their scale by 4. So every 1.5 boxes are pi quarters. So what did they make our scale by? This is 1/2. This thing says pi sixes, right? So what's half of a pi 6? A pi 12th. So this line is pi 12ths, and every single line is pi 12. So 1 pi 12th, 2 pi 12th is pi 6. 3 pi 12th, 4. So our one answer here is pi 12ths. Our next answer, I would go 1, 2, 3, 4, 5 pi 12ths, right? Then this next one, this was 5, so 6 pi 12ths, pi halves, that makes sense. 7 pi 12ths. 8, 9, 10, 11 pi 12ths. Is there a pattern? Are we always going up by something there? Do you see a pattern? Pi 12ths, and then we go up by 4 pi 12ths, but then we go up by 2 pi 12ths, and then we go up by 4 pi 12ths. So is there some general solutions we could write? We could write pi 12 plus or minus 1/2 pi, or like the period length, right? Which is our period length, which is pi halves, right? So our general solution could be that x, such that x is equal to pi 12ths plus or minus n pi halves. N is an element of the integers, as well as, so, and x is equal to 5 pi 12ths plus or minus n pi halves. N is an element of the integers. If you just wrote this and this, I would be happy in pre-calc. N, the intersection. This one and this one, right? So realistically, if it happens in a period length, those are the two ones you need to know about. Then everything else is a period length away with sine and cos. So we're going to carry on here and look at example 4. The graph of v is equal to 170 sine of 120 pi t is an approximate solution. So this is probably like it says the velocity of something happens at this with time being in seconds or something like that. So when we do that, the velocity, whatever this is equal to, because normally we have y is equal to this, x, whatever is out front, this is going to be your y value. Whatever's inside the equation that's a variable will be your x. Okay? So, solve for when this equation is equal to 50. Well, this equation is equal to 50 here, 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 and here between 0 and 0.03. So what are those values? It just says to approximate the solutions, right? So we know that every single one is 0.005. So this is actually going to be what? 0.0025. And you think that's what? 0.001? It's just an approximation. If someone was a little bit further off. And what's the other one here? I think you're right there, because that one falls right on the line. Now, what's the period length in this? Do we know? It's hard to tell, right, because it falls right here. So we'd have to add that. So it's probably just as easy just to read it off the graph than to figure out what we're going to add. So when I look at here, this is 0.015, and this is 0.02. So this is going to be 0.0175, and then right here 0.024, right? Could you do B? Gonna give you time to try B and see if you can come up with that. How'd we do? What did you end up to be your answer? When is this equal to negative 120? Did you say like right in here, and right in here, and right in here? Did you include this one? Because it's past 0.03. What did you guys estimate? Like 0.01, 0.015, or around that? And like 0.027 or something, or yeah, something like that. So as long as you're estimating, this is where I allow, if I give you the graph and you're asked to estimate it, get close. Try and get close, because if you estimated 0.028 for that, I would make it wrong, right? Because that's over the line. That's not even close to where it actually is on the graph. Where is it equal to 0? Here at 0, here, and then here. This is at, we kind of should figure out that period length then. How do we know what the period length is? We can find period length. How? By looking at the b value. What's our b value? 120 pi, right? What's the period length of sine? 2 pi. So if we divide by 120 pi, it's just 2 divided by 120, which is just 1/60th, right? So your period length is 1/60th. So it's 0 plus or minus 1/60th. I would almost put the 160 in front of the end, right? And then we would need this second number. Where is it hitting right here? Well, that's half of 1/60th. What's half of 1/60th? 1/20th, right? So you can actually come up with those numbers quite easily. It's just whether or not you want to take the time to come up with them. But they're really not that bad to actually get them, especially if you know what the b value is. If they give you the formula, it's easy to find the period length, right? You just have to know that sine or cos is 2 pi divided by p. Tan is pi divided by b. This just keeps on going over and over and over and over and over again. Once you get the equations, it's kind of easy. It's just the fact that when you're doing this in your calculator, you have to make sure, like your calculator, when you type it in, you're going to type 16 cos, and then it'll do this bracket, and that's okay. Put your 5, but then put another bracket so you separate that b out. X plus 1, n bracket, minus 5. The other way you could enter it into your calculator is 16 cos 5x plus 5 minus 5. How can I do this? It's just the distributing. I prefer that you do this all the time, and then you make another line at 3, and you solve for the answer. I think you guys could put those in and find the intersect points using second intersect. You're looking at me like I'm crazy. You okay? No? Yes? You're just zoning out? Okay. So basically, when you're doing this by graph and calculator, you input the one side of the equation, you input the other side of the equation, and then you find the intersects. Okay? I'll do this first one so you can see it though. So the one equation is 16 cos 5 bracket x plus 1 n bracket minus 5. The other one is 3. Now, my windows are set 0 to 730. Do I need them set like that? I'm going to change it to 0. You could do it just to 180, because then all your answers that you find are going to be it. But if it hits right at 180 and 3, it's hard to see. So lots of times I say, do a couple more degrees, or do the next 10. Just make sure that you don't include those as part of your answers. Okay? And my y min and max needs to be something else. I have an amplitude of 16, do I not? So probably negative 20 and 20. Oh, but I have a shift, you guys. I have a vertical shift of negative 5. So negative 5 minus 16, I have to be like negative 25 if I really want. Negative 25, and I could have a max at 0. Could I have a max at 0? 10? 15. 16 plus minus 5 is 11, so I need at least 11. So if I graph it, looks like that. It's been shifted down. We knew it was shifting down 5. These are our intersect points. How do we find them? Second, trace, intersect. Bring that little thing over here. Now, once I find my first two, do I have to go find the intersects like this? I can just plus or minus a period length after that, right? So here, this is 11 and 3. So what does that mean? My x value could be 11. And then I'm going to do a second intersect again. And we get 59. So we have 11 and 59 as part of our answers for A. And when we do that, how do I know my period length? Well, I know my B value is 5, and I'm at degrees, right? So the period length for cos is 360. 360 divided by 5 will give me my new period length. 360 divided by 5 is it 72 or something like that? So it's really 11 plus 72 to get my next number. That gives me 83. 83 plus 72 is 155. That still falls in the 180, but if I add another 72, I'm going to be over 180. So right now, I have an answer of 11, 83, and 155, but I also have to do this 59 answer. 59 plus 72, 131. If I add another 72, 131, it's 200, it's over the 180 degrees they want our answer. So these 5 are our answer just by using our calculators and solving. We're going to stop here. This is a big thing. But if you understand what we're doing is good, we'll finish come Monday. And then you'll have some time Monday to work on the assignment. Tuesday, we'll do a review. Wednesday, you'll hand in the review. Do you see where this is going? Thursday, you'll get it back. Friday is an exam next week. We have our life planned out next week.